All right, Math Leaguers, I'm back again. 30 seconds later, after I just did the joke for week 4. This is our final week 4 wrap up. I do want to say awesome job for people in session 2 and also the people that did both sessions. Great job. I see so many correct answers. I see so many great bonus tasks completed. You guys did so great on the Kahoot. We love having you as a part of this thing. And like I said, this is the ground floor. You guys are in on the ground floor of something special. And we're really hoping that you're going to be a part of helping us build this thing into something even more special. I'm just going to dive right into some of the problems for the week. I'll post the answers so you can find those posted. But some of the problems, just to go through some of them. Problem number 1. It said that there were 3 angles that were in a 3 to 4 to 5 ratio. So, it could be like 30, 40, 50, like 3 10s, 4 10s, 5 10s. It could be, 12, 16, 20, right? 3 4s, 4 4s, 5 4s, but they all have to add up to 180, okay? So I just said 3x's plus 4x's plus 5x's equals 180. That's 12x's is 180, and divide by 12, x equals 15. Okay, I chose x as a variable, and it said what's the largest angle? Well, the largest angle is the 5x, so 5 times 15 is 75. So 75 was the answer. Question number 2, I'm going to bring up something really controversial. All right, it's not really controversial. But it's something I do in my class. Some teachers don't really love it. But question number 2 said, if w is a positive integer, how many values of w satisfy this inequality? 10 is less than negative w plus 13. Okay. I do this thing, instead of adding w to both sides, on an equation or an inequality, I do this thing where you can take any term and you can move it to the other side. I call it flinging. Fling it to the other side of an equation or an inequality, and when it gets to the other side, the sign on it changes. So if I have a negative w on the right-hand side of this inequality, I go, and it becomes a positive w on the left-hand side of this inequality. It works for equals, right? And then I'm going to do the same thing with the 10. I'm going to fling the 10 over. It's a positive 10 over here, becomes a negative 10, and 13 minus 10 is 3. This makes this an easy problem now. If I said, if w is a positive integer, how many positive integers satisfy w is less than 3? Well, remember, 0 is not positive, so the only numbers are 1 and 2. The only integers that are less than 3 are 1 and 2. So there's 2 of them. It said how many. I go back to question 4. I just think I can't believe this actually works. I spent a lot of time on that on the hints video. So if you want to go back and look at the hints video, I think this is a really cool problem. But it says, in a 3, 4, 5 right triangle, what is the shortest distance from here to here? Well, the shortest distance from there to there is a direct line, so it's going to make a 90-degree angle. Anyway, it turns out that in a right triangle, the shortest distance from here to the hypotenuse, it actually works, is you literally do like base times height, leg times leg, divided by hypotenuse, and it works. So the length of this line is 2.4 units. Crazy. All right. Number 5, it said that a is a negative integer. It says that the median is 5 less than the mean. So it's what's a? All right, well, this is the set of numbers. You want to line them up from lowest to highest. It says that it says in the problem a is a negative integer. So a has to be the lowest. 12 is the next lowest, then 14, then 38, then 45. It says that the median is 5 less than the mean. Well, the median has to be 14 once we've got them lined up. So that means the mean has to be 19. And if you have 5 numbers whose mean is 19, then like the easiest way to get a mean of 19 is like all 19s, and like 5 19s would be 95, right? So it's like 95, like total points or sum of all the numbers is 95, divided by 5 is 19, okay? So then I just add up all these, and a little trick here, 12 and 38 is 50, and 45 is 95, right? So that's 95. So that's right where we need to be. So if I add 14 here, I gotta subtract 14 there, right, to balance that out. So that's negative 14, and that adds up to 95, and we're good to go. That was a fun problem. Question number 8. Question number 8 said, the product of 3 numbers A, B, and C is 2004. What is the lowest sum of those numbers? Now, you may have learned over the course of this, if we want a low sum, we want like the numbers scrunched in the middle. We don't want the like biggest and smallest. What I mean by that, like we could say 2004 is 1 times 1 times 2004, right? The product of 3 numbers is 2004, but the sum is really big. The sum is 2006. Even if I said 1 times 2 times 1002, well, I get a much lower sum just by slightly squeezing the numbers together, right? Making, 2 is bigger than 1, 1002 is smaller than 2004. That's a sum of only 1005, right? So then really all I did was I broke down 2004 and I did the prime factorization thing. I could have done 2 and 1002. I just thought I'll do 4 and 501. Remember, 501 almost looks like a prime number. Like a lot of times something 01, a lot of times it's gonna be a prime number. But you remember the 3 rule, if you add up the digits and the sum of the digits is divisible by 3, then that number is divisible by 3. So it turns out 501 divided by 3 is 167, okay? And again, we don't want to use big numbers. These are the smallest numbers we can use. There's only 3 of them, so there's no need to break that down, 2 and 2, because that would 2 times 3 times 167 would be 4 numbers. So these are 3 numbers, and they add up to 174. That's the lowest sum we could have. The highest sum we could have would be like 2006. Okay, 1, 1, and 2004. Question number 12 and 13. That I went over this one in the hints video. It says somebody put their pencil there. They went to there to 2, 2. They went over to 7, 2. They went over to 9, 2, and then they went back there. And the first question was, what was the area of the trapezoid? Well, the area of the trapezoid is base 1 plus base 2 divided by 2 times the height. 9 plus 5 is 14, divided by 2 is 7, times the height. Well, the highest right there, the height is 2 because we went up to 2. So it's 14 times, so it's 7 times 2, which is 14. So number 12 was the area of a trapezoid, and that was 14. Number 13 said, what's the perimeter of the trapezoid? And again, I went over this one in the hints video. If we go up 2 over 2, okay, then that means we're going like up 1 over 1. We're going at a 45-degree angle. In fact, we know this because up 2 over 2, we've gone 2 there and we've gone 2 there. And it's one of those special right triangle triples. If the 2 legs are the same length, then these must be 45-degree angles. It must be a 45, 45, 90 right triangle, okay? And if that's the case, the hypotenuse is square root of 2 times the length of one of the legs. Okay, so 2 times the square root of 2. Now, we wanted the perimeter of this whole thing, and it's to the nearest whole number. So you would literally just type square root of 2. A little trick, I don't know if you know this, square root is also, like if you like to use the power button, the square root is the half power. So you could raise to the half power. That's the same thing as taking the square root. Don't know if you guys knew that. Anyway, the square root of 2 is about 1.4. And 2 of those is about 2.8. Okay, so this is about 2.8 there. And then of course this is about 2.8 there. And it's actually a tiny bit more, but it's about. And then 5 plus 2.8 plus 9 plus 2.8. These two 2.8s are 5.6. And then 9 and 5 is 14, so that's like 19.6-ish. And it asks for the nearest whole number, which of course is 20. All right, number 14, I'm just gonna remind you, these little math counts things, how many diagonals does a certain kind of polygon have? There's patterns, we've done a lot of these, especially if you've been with us for both sessions, but there is a formula. The number of sides times the number of sides minus 3 divided by 2 will give you the number of diagonals for that shape. So it was an 11agon, okay? So 11 times 8 is 88 divided by 2, 44. So an 11-sided polygon has 44 diagonals. Finally, number 15, I like to go over this one because it's a little tricky. I know a lot of you know the trick to finding the sum of like an arithmetic series. But sometimes the trick is in figuring out where that series ends. Like it says the first 55 numbers of this series, 4, 9, 14, 19, 24. You can see that we're going up by 5, okay? So we want to know what's the last number, what's the 55th number? Well, you don't want to have to sit there and be like, all right, 29, 34, 39, 40, and count them all up. You want to quickly get to what's the last number. Okay, well, think about this. You're going up by 5. You're jumping by 5, right? Well, the second number is the number of jumps, right? One jump to get to the second number. One jump, okay? Or the number of jumps, one jump, times the distance of the jump, 5, right? 5 is the distance, okay? Plus the starting number, 4, is 9. The third number, 2 jumps, 2 5s, so it's 5 times 2, the distance of the jump, times the number of jumps, 2, okay? 2 times 5 is 10, plus the starting number, 4 is 14. So the 55th number, if you can see, if there's 2 numbers, there's 1 jump. If there's 3 numbers, there's 2 jumps. If there's 4 numbers, there's 3 jumps. So the number of jumps is always 1 less than the number of numbers because you're starting off with a number itself and then you start jumping. So 54, there'll be 50, if there's 55 numbers, there's 54 jumps times the distance of a jump. So 54 times 5 is 270 plus the beginning, which is 4. So the last number is 274, okay? And then we can do that thing. You can say the previous one before that is 269. And you can do that trick where you pair them off, right? 4 and 274 is 278. 9 and 269 is 278, right? So every pair is worth 278. How many pairs are there? Well, if there's 55 numbers, this gets a little weird, that's not a number. So you just divide by 2. How many pairs are there? 55 divided by 2 is 27 and a half times 278. I don't even know what that is. I'm not gonna do long multiplication on here, whatever that came out to. That's the answer. And great job. And like I said, keep your eyes open for the posts, for the raffle winners, for the award recognitions. All that's coming. Thank you very much. Tell all your friends. And we are going to be doing some things during the school year, not a whole lot, but keep your eyes on your posts and hopefully maybe your emails and stuff like that.